Hello, I'm Nobby Clark. Welcome to my workshop. I'm actually recording the introduction to this video at the end, but it's going to go at the beginning. Rather back to front way of doing it, but there we are. The project is to make another Morse taper 2 arbour. In this case, to use a chamfering tool in the end here. I'd already shown at the end of the video that I have two others. This one I made a little while back. So I've got two of these with different size centre drills. This one is a commercially made arbour. And I do have another one of these, which I've sort of kept to one side so that I could actually use that to set the lathe to the compound to the correct angle. The material I'm using is a piece of this huge bolt that was given to me. It's, as everyone says, mystery metal. I think this bolt could be anything up to 100 years old. It's something to do with the railways, I gather. So really, no idea, I suppose, what the machinability of it is really, but it was worth an experiment with this, just to see how I could get on and really see whether this material will be used for any other projects in the future. It's quite a long video, this one. What I've done is just record it in a number of sequences. In fact, the video was made over a number of days to get to the final stage. But I hope you enjoy it. It does show quite a lot of machining going on the Myford lathe and various other bits and pieces that I'll show you at the end as well. Various accessories that I've made for the Myford to help in projects like this. Anyway, well, I hope you enjoy it. So without further ado, let's get on with the job. Well, I think that's set up reasonably good. This is an MT2 taper arbour. I've got one of these which has a softer machinable end, and so I'm using this to set up the angle on the compound slide here. And I'm using my new to me dial indicator here. This was a very kind gift to the channel. I think the donator of this saw my video where I showed the small Morse dial gauge in this block that I'd made, and it's only one of a couple of dial indicators that I actually own. I was going to use that dial to dial this angle in, but to set this up, the probe on the Mercer one didn't have enough reach to enable me to turn the handle of the compound along without it hitting the tailstock. So this new dial indicator's come in very, very handy because it has a much longer reach on the probe here. It's a nice big clear dial, which I hope you can see clearly. And it sort of just about fits into the holder. It's very, very tight into the edge here, but it's clamped in nice and firmly, and I think it's going to be a good alternative for setups like this. But anyway, now I've got that all set and the compounds all locked into place, I can move along and start a new project. Well, that seemed to work okay. This old steel bolt, I knew I'd find a good use for a piece of it at some time, and I've cut a chunk off here. The old Sheepak bandsaw worked really well on that. You know, just imagine how long that would have taken me to cut through that with a hacksaw, and I'm not out of breath at all using this. That's really good, very pleased. So can now move on to the next stage after I've sort of deep board, deep. Had to clean up on the end of this. We'll see how we get on. I know this is something I'm never going to get running perfectly because this is very rusty metal and very uneven surface. I think it's just really a matter of getting it as near as I can. I've tried sort of like knocking it into position, but I think, you know, at the end of the day that's probably about as good as I'll get it. What I want to do is to face at the end off here and cut a centre into it so I can support it with a revolving centre, so that it's going to hold it in as good a position as I can get it. I did try running the material, and it's running as well as I can see. I was confusing with the screw thread on that actually, to actually see whether it's level or not, but at least the operation I'm doing here, it is going to sort of centre it all up. Let's see how I get on trying to face the end of it. that seems to have got it. The end of the metal here was at a bit of an angle, so there's a sort of very sort of deep area in here which appeared to have got out. Now let's see if I can get a centre into this. Seems to have worked. I've managed to get a centre into that without breaking it. Revolving centre in, leaving plenty of room on the quill here as well. So the next job is I've got to mark this out for length and bring the metal down to the sort of maximum size, you know, with the Morse taper 2 here, bring it down to sort of near to this diameter here. This operation obviously is going to take quite a long time to do, so I think I'm going to do most of this off camera, and then when I'm sort of getting nearer to size, I'll bring you back at that point. Right, now I've already brought the material down to diameter, which did actually take quite a long time, so that's why I didn't really bring you back for that. But the stage now is machining the taper. I'm using one of these button tools because that gives about the best surface I've found, and that's what I use to get the material here down to its final diameter. Important thing is to have the compound in a position that you've got enough travel to cover the whole length here. With the Morse taper 2, the compound just about has enough travel to do this, but on making some Morse taper cleaners where I was machining some wood, I found that with the Morse taper 3, the Myford compound slide doesn't actually have enough travel for that, but obviously with this job that's not going to be a problem. So what we're going to do is touch off here and then start machining the taper. I'll only show part of this because again it's quite a long process. It's a bit of a stop and start process because I've got to keep taking measurements as well. I've already jotted down the diameter, final diameter here, which that is already almost machined to, and I know the diameter at this end, what's required here. So we'll make a start on that now. That will give you a bit of an idea of what's going on. I'll stop filming now, and then I'll bring you back when I'm getting near to completing the taper. I'm making cuts of about 5/1000ths at a time, and obviously I can cut in both directions. We're pretty much at the final stage now, so what I want to do is take just a couple of quite light passes to check the taper angle. I've been using this is a 3:2 reduction sleeve, and make sure the inside of this is nice and clean, so I can use one of my Morse taper 2 cleaning sticks just to make sure the inside of that is perfectly clean first. Now we draw that in and probably take a couple of passes at, you know, sort of 1 or 2 thousandths. sand the surface to try and get a nice smooth surface, and I've got a piece of 240 grit belt sander material, so I'm going to use that to clean this up. Try the adapter on that. It's not going to go right to the end. In fact, this is a commercially made Morse taper 2, which has a machinable end, and this one I've adapted to take a centre drill. And you'll see that doesn't go right to the end anyway, so there's hopefully enough contact there. Doesn't seem to be any wobble in it then. Unfortunately, I don't have any micrometer blue, which would be absolutely perfect to put some on here just to check that I've got contact all the way down. I have already made a Morse taper 2 adapter before, and I just used some blue marker pen. Just put plenty of that on there. Doesn't matter if it dries out a little bit, because basically the adapter hopefully will sort of scratch the surface. Try and put this on and twist that without jamming it on. Well, I've got good contact here and a bit here. Some contact in the centre there, so I guess if I do a bit more sanding this end and a little bit here, hopefully I can sort of bring that into better contact. But I guess, you know, even with the contact at both of those ends, it's going to work. But let's see if I can clean that up a bit better. Well, certainly it's getting better. I'm getting more contact a bit further down, slightly better contact here, and slight signs here, so I think if I do a bit more polishing I can probably improve that more. So I'm going to carry on with that and bring you back once I've got it looking a bit better. Well, I've done a bit more work on the taper. In my over enthusiasm to try and get a better surface, I made the taper a bit too small, made it too loose a fit on the test piece here. So the cure for that was to just machine this bit out a little bit longer, so that there's actually, I'm sort of back to where I was before. When I've got a reasonably good fit, I've done a bit of polishing on it as well, and I've got as good a fit as I possibly can. I mean, at the end this is going to be used as an arbour. I think this one's going to be for a chamfering bit that I can use in the tailstock. Putting that on, try and get it on there without jamming it in place. And I've got a sort of contact here, plenty of contact along there, and you can only see sort of very slight contact there, but there is some contact points in it, so I think I'm going to leave it at that. The final stage will be just to turn a bit of relief on the end here. This isn't going to be one with a tang. I might possibly shorten this a little bit, and what I did with the original one that I made, I just made a little bit of relief on the end, although I don't think the length of that's gonna hurt. I can actually try this in the tailstock to make sure it's going to be okay. I've also put a chamfer here just to make it easy to do, because what I've got to do next is, after I've completed this end, is remove the chuck and turn it around and push this into the Morse 2 taper in the headstock of the lathe, and then clean up this bit here that only really needs cleaning up on the outside and facing on the end, and then at a later stage I can drill a hole in that to take a chamfering tool and cross drill it for a locking grub screw. But there we are. I'm sort of reasonably happy with it. I would have liked to have got a much nicer surface here. It's not too bad. I'll probably have another go at sanding it with various grits of sandpaper just to get it as smooth as I can, but whether it's the tools or whether it's the steel itself that's not giving the fantastic surface. But there we are. For the job it's intended for, it will do the job quite happily. So I'll wind this little sequence up. What I will do is bring you back when I'm completing this end here, just to show you the final stages of it. The next stage is to just machine all this rough material off here. It doesn't really matter about the diameter here at all really, and to complete facing at the end off here. I've removed the chuck from the lathe spindle, giving it a really good clean, and I've also already cleaned up inside the Morse taper here as well. Now while I'm doing this work, obviously putting the part into the Morse taper in the spindle, I want to protect the threads on here from any possible damage, and I have these wonderful spindle nose protectors. This is an aluminium one. I also have one made out of a plastic, machinable plastic material, and I can screw this onto the spindle. I've got the spindle locked so that I can screw it all the way in nice and tight. Get it in tight and then just release that, so that's can revolve quite happily now. These were made for me by one of my YouTube viewers and subscribers, David Ticehurst in Australia. Very kindly made these for me, because I've not done any screw thread turning on the lathe yet. It's something I must get round to teaching myself at some point, but not just yet. So I can now put that into the spindle, just gently knock that into place. That's it, and I'm just going to face off the end here and just machine this until it cleans it up nicely, and then obviously put a chamfer on the end. So I bring the tool in here, lock off the carriage, and away we go. think that's it. Got a reasonable finish here. I don't really know what this steel is from that big bolt, but it certainly doesn't machine as nicely as other materials I've used, but at the end of the day it's going to do the job. So all I need to do now is to remove that from the spindle. Use my bar to push that through. Actually, before I do that, that side, which I'd chamfered first, has ended up quite good. There's still a bit of a burr on that. I think I'll just lay a file on that. Much better. Don't really want any sharp edges on that. That's lovely. Okay, right. Let's remove that from the spindle. So that's it. Overall, not too bad. I would have liked to have got a much better finish to the taper on that, but as I say, we're not quite sure what this metal is, but it's certainly going to do the job. What I want to use this one for is the chamfering tool, and I quite like these types of chamfering tools, so I've got to find a drill of exactly the right diameter here so that I can mount this into here. It is actually a bit of an odd size, so I've got to find one that will give me a nice tight sliding fit into here. So really that does it, I think, for that part. So I think we can sort of wind this project up now. Well, that brings this little project to a close, making my Morse Taper 2 arbour so that I can mount a chamfering tool in it. This is the second one I've made, actually. This is one that I previously made. I did get a much better finish on this one. It was entirely different steel, sort of a nice machining quality, and I've mounted a centre drill in this. This was the first one I converted to a centre drill, but this was a commercially made Morse Taper arbour, so they've both been adapted in the same way. Just drilling a hole to give me a good tight fit for the chamfering tool, and drilling and tapping for a little grub screw in the side. So I've now got, well, 3 of these. I have actually got another commercially made one of these, which, you know, I can use for another tool in the future as well. While I was machining the taper, obviously I had a lot of material to remove here, and I just don't know what this steel is. It was, as I showed you at the beginning of the video, a very old rusty bolt. So it didn't machine brilliantly actually, but it's certainly going to do the job. But one thing with machining steel is, of course, it's throwing sort of hot chips around everywhere. So as a little device I made some time back is a chip shield. It's just basically this was a piece of material off a clipboard. I took the clip fastener off the end here. This angle arm is not an engineering product, it's something from the photographic industry to hold tiny little lights in place, but it does exactly the same job as a Noga arm basically. And I had this nice little clamp which just happened to have the right thread on to fit, so I clamped this to the handle here. That can be clamped on. Nice and tightly, and then I can adjust this to stop all the chips from flying up in the air and burning my arms. So that works quite nicely. I'd like to adapt it further if I can, and perhaps have a guard over the top here as well to sort of try and contain all the chips around the lathe rather than all over the floor, but that's something to do a little bit later on. Something also, while we're on the Myford lathe, something I made up a means of holding the lathe tools near the lathe all the time. You can't see it in the image here, but down there is a little tray fixed to the lathe stand, and I keep the various tools that I need for the lathe there, so they're nice and handy. But I ended up piling the lathe tools into there or on the bench behind me, so I made up this simple bracket here. It's just a piece of scrap wood with some little angle brackets that I bought from, actually I think it was from somewhere like Lidl. So I've mounted a few of these on here so that I can just slide the tools on. This is not an exact fit for here, but having angled it, gravity, oops, I'll get it on there, gravity holds them in place. So I can get 5 tools on here, and 5 tools that I'm using for any particular job. Sometimes I do need an extra one, but 5 sort of covers basically what I want for the job itself. But there were just a couple of extra bits of information on what I've done with the Myford lathe. Anyway, thank you very, very much for joining me in the workshop for this project. I hope it's been interesting. At least you see a bit of machining carrying on. Thank you also to all the subscribers to the channel and all the nice commenters to the channel as well. Hope to have another video for you very, very soon, so bye bye for now.